Okay, so what we're going to do, and this is what you're going to do with all your homework here, is 1 through 19 odd. You're doing these both ways. So let's do 13 both ways. The first way I'm going to do it is long division. And long division is just like it sounds. It's like, what do I do if I were to divide 4 into 78, for instance? I would go 4 goes into 7 one time. I would write how many times it goes above the 7. I would then say 1 times 4 is 4. I would write it here. And then I would subtract. 7 minus 4 is 3. And then remember, I bring down the 8 and I do the whole thing over again. We kind of have to remember how long division works in order to do our lesson today. So let's look at what does that look like when I have an equation that looks like this. You look at 13. You're taking this big long equation and you're dividing it by x squared plus 2x plus 1. I kind of wish I had not picked this one because it's not the most simple one of the bunch. But oh well. Here we go. We'll start with one that's more difficult. Okay. What I can do here is this. I can say, all right, I'm going to have to write the whole top down. Before I write it down in my long division bracket, I got to make sure that I've got every single term. And here's what I mean by that. On the top, I've got a cube term. That's the biggest one I've got. So I need to have every term underneath it. I have to have a square term. This is an x to the first term. And then I got to have a constant term. If I'm missing any terms, I have to fill in with a 0. Like if, let's say I was missing the x squared term, I would have had to fill in with plus 0x squared and use that 0. I would have had to write it under here. We'll pick one in a minute that's missing one. Okay, so here we go. You got, what I'm going to do is I'm going to write it down. Again, this book gives you challenging problems. It does not give you the simplest kind of things it could. And then I'm dividing by the thing underneath it, this right here, so I put this on the outside. If you forget to fill in a term and it's missing, like if you were missing the x squared term, you're just going to end up with a big mess. So I'm kind of warning you, you want to make sure you look out for that before you get going or you're going to regret it. I'll probably go over and start over. All right, so when I'm doing this, I'm saying, okay, I'm going to take the x cubed. I'm going to say how many times does x squared go into x cubed? X cubed divide out of x squared, what would be left over, in other words? You have an x left over? If you need to, come up here, x cubed divide out of x squared. Wouldn't that be x, right? So I'm going to put an x here. Remember, in long division, when I put a number above, then I have to multiply that number by everything that's out that I'm dividing by. Up in long division, it was just 1 times 4 is 4 on the example above. But here, I got 3 things to multiply by. So here we go. X times x squared is x cubed. X times 2x is 2x squared, isn't it? And x times 1 is x. Okay, so I got my result. When I got my result in my little division problem, didn't I then have to subtract it from what I had? So I'm going to subtract, but I got to subtract every single term. That minus sign goes with every term. Now some people like to go put it up next to everything, but I find that when I do that, I get lost. If I have to backtrack, I forget what was there and what I put there. So here's what I'm going to do. I'm going to say x cubed minus x cubed. Wouldn't that be 0? Because they cancel out, so I'm just going to go, okay, those canceled out. Yay, that's what I wanted that to happen. If it didn't happen, I've done something wrong, actually. Then I'm looking at this 3x squared minus 2x squared. What's 3x squared minus 2x squared? Wouldn't it just be x squared? Please tell me y'all aren't that lost and that you're just being shy. Okay, I need y'all to speak up. Okay, 3x squared minus 2x squared is 1x squared. Okay, so that's going to be an x squared here. Now I have a 3x, and I subtract an x out. Remember, that's 3x minus 1x. What's 3x minus 1x? 2x. It's a positive 2x, okay? So that's my remainder so far. Now I need to drop down the next term. I've used all these terms up. Let me put a little red check. Haven't I used all these in my subtraction so far? So all I got to do is drop the 1 down because I've already kind of dealt with all those. It's not like if I've brought a term down, I don't need to bring it down again, and it is how you look at it. So I'm going to bring down a 1. Okay, so now I'm going to say, all right, I got an x squared here. Again, you're just looking at the first term out of your expression and the first term over here. How many times does x squared go into x squared? 1. So I'm going to put, it goes in positive 1 time, so I'm going to put a plus 1. Okay. Then I've got a number up here. When I have a number up here in regular division, didn't I always take the number up here and multiply by what I divided by as the next step? I would say 1 times x squared is x squared. 1 times 2x is 2x. And 1 times 1 is 1. So when I get a number up here, I got to multiply it by everything over there that was out front. Now I'm done. Because if you look, don't I now subtract all that? I got to subtract the whole thing. And it's a good thing, because look at those things. Aren't they equal? If you have something and you subtract the same exact thing, isn't everything going to cancel out? X squared minus x squared cancels out. 2x minus 2x cancels out. 1 minus 1 cancels out. Ooh, I have a remainder of 0. This thing went in evenly, didn't it? So my result, when I divided this out, it ended up being, what do I have up there? Although it's in different colors, I have x plus 1. Actually, this is a way I can actually factor things. If you know one factor and you don't feel like thinking about factoring another way, you could always do this. You could always divide things out this way. So sometimes they use stuff like this to factor. Sometimes you just, like, there are times, though, I'll be honest with you, we don't even do this much in calculus, but there are times like in advanced calculus when you might need to divide this out and simplify and rewrite something. We do this maybe a little bit in pre-cal. There's a time I can think of that we do this. That's long division. I want you to skip the synthetic division on this. I'm going to go back and change the assignment a little bit. We're only going to do synthetic division, and I'll write it here so that I've got a place to go back and look. We're going to do it on 1, 7, 9, 11, and 19. Okay, so for number 17, I'm going to actually we'll do both, okay? So let me write it down. If you look at 17 and you list out all the terms, everything's there. Your biggest exponent is 4. You got an x with a 3 on it, x squared. You got an x, and you got a constant. So everybody's there. You're not missing anybody. If you were missing anybody, you'd have to fill in with a 0. And again, I didn't pick one, but this will be at least one that I didn't list that we could use it as an example. So if I'm going to do long division, I just write it like this. Okay, and I go, all right, I've got an x to the 4th, and first I'm going to divide an x out of that. I got to start with the first term. If I have an x to the 4th and I divide an x out, wouldn't I have an x cubed left over? I'm going to write that down, and then what do I do with it when I write it down? I multiply it out, right, by both of those things. So x cubed times x is x 4th, and x cubed times 6 is 6x cubed. What do I do next? Yep, subtract. So I got to put everything in parentheses because I got to subtract both terms. If you need to go off to the side to do this, you could. I'm not going to do that because I don't have the space on the iPad. Yes. Yeah, that x to the 4th minus x to the 4th, those go away, and that always should go away if you picked it right. Yeah, 7x cubed minus 6x cubed is, Misha's saying, x cubed. Okay. Wouldn't 7 of them minus 6 of them be one of them, right? Yeah, okay, so it would be x cubed. I'll write that down. And the next thing I'm going to do, I used up my x cubed term, so I'm going to bring down my x squared term, my 5x squared term, because I already have messed with that x cubed term. Okay, so now what I'm thinking is, all right, I'm going to switch colors every time I start doing a new thing here. I got an x cubed term. I'm dividing an x out of it. X cubed divided by x, what would be left? Wouldn't it be x squared? right?
Oh, we said what's left.
What's left, yeah. So x squared, and now I got to multiply both of these times what's out front. Covering up my answer, and that's not good. X squared times x is x cubed. X squared times 6 is 6x squared. I write it down, but I got to subtract both of them. Okay. What's x cubed minus x cubed when I actually go do that subtraction? It's 0. They cancel out, right? What's 5x squared minus 6x squared? Yeah, negative 1x squared or negative x squared. I'll put the 1 out just because it might help us a little bit here. I don't know. So I have that result, and now I got to bring down the next thing that I haven't messed with at minus 8x. Okay. Now I say, if I have a negative x squared and to divide an x out of it, what's left? Again, negative x squared, take an x out of it. You could go off to the side and write it this way. Wouldn't this x cancel out one of the x's on top when you have a minus x left over? Right? Okay. So you'd say, okay, now I got to multiply it by everything out front. Minus x times x is negative x squared. Minus x times 6 is minus 6x. But I got to subtract all that. Now here's where it's going to get a little tricky. Aren't I going to have two negatives in a minute? For instance, I've got negative 1x squared minus minus x squared. Isn't that minus 1x squared plus x squared? Don't two minuses make a positive, right? So wouldn't those cancel out? And then I have negative 8x. I'll come over here, negative 8x minus minus 6x. Wouldn't that become negative 8x plus 6x? And wouldn't that be negative 2x? Okay, so this would be negative 2x. Do I have something still to bring down? Yeah, I have that minus 14. Let me bring it on down. Okay, so now I'm saying I got a negative 2x. I'm going to divide an x out of it. If I have negative 2x and I divide x out of it, what's going to be left? Again, come off to the side if you need to. Negative 2x, divide x out of it. Wouldn't it just be a negative 2? And the x's cancel out. Okay, so I got to multiply that times everything out front. Negative 2, let me write it up here because I'm running out of room here. Negative 2x minus 14. Negative 2 times x is negative 2x. Negative 2 times 6 is negative 12. But I got to subtract everything, don't I? So negative 2x minus minus 2x. Doesn't that become negative 2x plus 2x? And that cancels out, doesn't it? Then I've got a negative 14, I'll come off to the side, minus a minus 12. Two negatives make a positive. So that's going to be a negative 2 left over, isn't it? Negative 14 plus 12 would be negative 2. So I have a remainder of negative 2, and I'm going to write this up here. I'll write it in bright orange just because I want it to show up. So my remainder is minus 2 over... Remember how you can make a fraction out of it by putting it over what you divided by? My answer would be x cubed plus x squared minus x minus 2 over x plus 6. I'm circling it there. Now I wrote over some of it as I was doing the work, but that's what's underneath it is what I just kind of said out loud.